An Introduction to Suomi NPP NASA VIIRS Data, presented by the Land Processes Distributed Active Archive Center, or LP DAAC. This video will provide information on data produced by NASA from the VIIRS instrument aboard the Suomi NPP satellite. An overview of the Suomi NPP VIIRS mission will be provided, as well as how to find out more from the LP DAAC website, how to understand the VIIRS file naming convention, and how to use the external metadata file. The VIIRS instrument operates on the Suomi NPP spacecraft, which is a joint mission between NOAA and NASA. The VIIRS satellite sensor provides a continuation of the Terra and Aqua Moderate Resolution Imaging Spectroradiometer, or MODIS, missions. VIIRS was launched on October 28, 2011, and orbits 824 kilometers, or 512 miles above the Earth's surface. At this elevation, the VIIRS swath width is 710 kilometers greater than MODIS's and has less gaps in coverage near the equator than MODIS. The orbit of this spacecraft allows VIIRS to capture the entire Earth every day, providing data products at two spatial resolutions, 375 and 750 meters, which are then resampled to 500 meters, 1 kilometer, and 0.05 degrees to promote consistency with the MODIS data products collection. The LP DAAC distributes land discipline-related NASA VIIRS data products. One of the first places to learn more about Suomi NPP NASA VIIRS data is the LP DAAC's website, lpdaac.usgs.gov. In-depth information about Suomi NPP NASA VIIRS data can be found under the Dataset Discovery tab. Hover over Dataset Discovery, then hover over VIIRS and click on the VIIRS Products table. The VIIRS Products table lists all of the Suomi NPP NASA VIIRS products distributed by NASA's LP DAAC. The table provides information on the product short name, the dataset, the pixel size, the product, and the temporal granularity. Clicking on the hyperlinked name leads to more product information. Each VIIRS data product has a Digital Object Identifier, or DOI, and with that, a web page that provides important information. Each page has the same layout. At the top of the DOI landing page is the data product short name and long name. The description section contains a brief description of the product. The description section also contains the necessary information for properly citing the data product, including the DOI and a citation generator. To the right of the description section is a visual sample example from the product, a brief informational outline about the product, and the tools that can be used to access the data. The next section on the DOI landing page describes characteristics of the data, including high-level information about the collection or product family and the granules in the collection. Below that is information about each of the data layers contained in the hierarchical data format, or HDF file. This section also provides links to information about the product quality, which looks at quality control aspects of each pixel in the product and any known issues with the data. The third section provides links to documentation that relates to that specific data product. These documentation sources include the user guide, which provides a more in-depth and up-to-date explanation of the product, and the Algorithm Theoretical Basis Document, or ATBD, which provides descriptions of the algorithms and calculations that are fundamental to the product. The fourth section lists the tools that provide users with the ability to download and explore the data product. This section also contains information about services that enable users to reproject, subset, and download data in a different file format. The final section provides e-learning resources from the LP DAAC. These resources include tutorials, use cases, scripts, videos, and past webinars and presentations that relate to the data product. The e-learning table is searchable. For example, type Python in the search bar to bring up the e-learning resources that relate to the product and Python. In this case, the resource is a webinar and presentation on using R and Python with land remote sensing data. Now that the product information on the LP DAAC website has been explained, information on how to read the VIIRS file name will be discussed. The VIIRS file name itself can tell users a lot about the granule without needing to preview it. Here is an example of a Granule ID. The first part of the Granule ID is the product short name. The second part indicates the Julian date of acquisition. The third part indicates the location of the granule based on the VIIRS sinusoidal tile system, which is the same as the MODIS sinusoidal horizontal vertical tile system. The fourth part indicates the product version. The fifth part indicates the Julian date of production, including the year, day, hours, minutes, and seconds in UTC. The last part is the file extension. VIIRS data are provided in the HDF EOS5 file format. Another great place to find information about the data is the external metadata file, which is provided in XML format. The XML file is available through any data access client used to download Suomi NPP NASA VIIRS data. Metadata is data about data. Granule level metadata provides useful information about each specific data file. This metadata file includes the data product DOI link, which is needed to properly cite the data. It also provides additional information like the granule's corner coordinate boundaries. Thank you for watching our video. To learn more about Suomi NPP NASA VIIRS data products, please visit lpdaac.usgs.gov.